Okay, so let's look at 38. It says let f be the function given by the following. And what I want to do is find what is the least value. So what is the smallest x value from which you see for which the graph of f changes concavity. So if I'm changing concavity, I'm looking at, again, the second derivative. And I want to see a sign change either from positive to negative or from negative to positive. It doesn't mean it's just going to hit the x-axis, but it also has to change signs. Now, if I put this position function into my calculator, I'm going to have, it is cosine of 2x, and then we're going to add the natural log of 3x. So adding the natural log of 3x, if I'm looking at this for the concavity, I only need to see the graph of y3. So I'm going to come over here and I'm going to turn off the first function, and I'm going to come over here and turn on the third one because this is the second derivative. And you'll see here in just a bit, if I press zoom 7, because I do have part trigonometric function, we want to use zoom 7, not zoom 6. It gives you a clearer picture. You notice that we have an error. It's a data type error. The reason why of this is I believe it's dealing with the fact that we have trigonometrics and logarithmics in the same function, and that's why it's erroring out. Now you can run into this problem at times, and the best thing to do is just to do it by hand and then insert it in y1. So if I take the derivative, okay, and the derivative of cosine is negative sine, it's of the stuff. Now this is chain rule because we still have to multiply by the derivative of what's inside here, which is just 2. And it's going to be plus, so natural log is 1 over this stuff times, again, the inside. So this 3 over 3, these are going to just cancel, and I can rewrite this as negative 2 sine of 2x is going to be added with 1 over x. So this is still f prime. And we're looking for concavity, so I need to get the second derivative. So let's find f double prime. And this will be, again, chain rule here. So just like here that I multiplied the derivative of the inside, I'm going to go ahead and do that now. Constant multiple rule says I can look at negative 2, kind of not even look at it, and just look for sine of 2x. And the sine of 2x is going to equal cosine of this stuff. Again, we're going to multiply by that 2, and then constant multiple rule this negative 2 back in. So it'll give me a negative 4. Now this right here, I can rewrite this as x to the negative 1, so that I have positive times negative 1 is a negative 1 over x to the positive 2. Okay, so if I were to take this independently, it's negative x to the negative 2, which would show that this is what I get. Now, like I said, if I graph this now in y1, so we'll come over here. Let me first turn off my second graph because I don't need it anymore. And we're going to go to y1, and we're going to end up graphing our second derivative that we solved by hand. Okay, so it's going to be negative 4. Let me clear this. Negative 4 cosine of 2x. Very seldom will this happen, but if it does, it's best to do it by hand and then graph. Minus 1 over x squared. Minus alpha y equals inner 1 over x squared. Okay, and now that I am going to graph this, again, zoom 7, because I have some part trig, you're going to see it now graph. So this x value here seems to be what we're looking for. So we have half, 0.9, 1.1, 2. So let's look for half and somewhere around this area here, because this could be the least. Alright, sorry about that. That was my dog trying to mess up the video. So whenever I graph this, I'm going to look for somewhere around 0.5, 0.9, because that's what I see right here as far as on the graph. I just need to find the x value, and I'm done. So second calc, it's going to be the 0 of the function because we're looking for those x-intercepts. And I'm going to get as close as I can to that 0 on the left side, and then now I want my right boundary. So get on the right side of that point. And then this guess, I could just press enter, or I could try to guess somewhere close to what I think the x-intercept is. So I get 0.931. From my choices, B is going to be my answer for 38.